in physics in 1930. Today, we have gathered to celebrate this legacy and to dive deep into his contributions that revolutionized the world of science. To enlighten us further, we have with us a highly distinguished guest, Professor P.K. Ahluwalia, the National President of IAPT, that is Indian Association of Physics Teachers. Students, let us welcome Sir with a big round of applause.
Thank you.
Sir is a visionary academician, a passionate educator, and a leader who has played a pivotal role in fostering scientific temper among students and educators alike. Sir, we are truly privileged to have you with us today. This insightful session is being hosted by IAPT Regional Council SRC08E Vidarbha under the leadership of respected Professor Shamkant Anwani. Anwani sir is HOD, Physics Department, Shivaji Science College, as well as sir is an esteemed president of Vidarbha IAPT. Professor Anwani sir will now take the stage to introduce our distinguished speaker. Before we begin, I would also like to extend our heartfelt gratitude to Dr. Govind Lakhotia sir, the dedicated coordinator of this event, whose efforts have seamlessly brought us all together on this platform. Thank you, sir, for making this webinar a reality. Sir, all our students are highly excited and eager for the webinar. So without further ado, I invite respected Professor Shamkant Anwani sir to introduce our honorable guest. Over to you, sir.
Thank you, madam. Am I audible?
Yes, sir.
Thank you very much, madam. I'm very happy to see budding students of Somalwar Nicholas branch and our own students of Shivaji Science College. I remember the great Maratha warrior Chhatrapati Shivaji Maharaj, and I remember the visionary professor Dr. D.P. Khandelwal, who formulated Indian Association of Physics Teachers in 1984 with like-minded persons of his era. This is the only organization of teachers who are active throughout the country with 22 regional councils and many sub-regional councils like us, that is sub-regional council for Vidarbha. IPT works closely with NCERT, UGC, DST and Olympiad. IPT conducts examinations like National Standard Examination in Physics, that is NSEP, and NGPE, that is National Graduate Physics Examination, and it is responsible for conducting science competitions and quizzes. IPT is responsible for organizing seminars, webinars, training workshops, and experimental physics sessions for teachers as well as students. Today, to address our students of Nagpur, we have with us Dr. P.K. Ahluwalia sir, who is Central President of Indian Association of Physics Teachers. We are assembled here to celebrate National Science Day, which is on every 28th of February in India to commemorate the discovery of Raman effect by Sir C.V. Raman. For his Raman effect, he was awarded Nobel Prize in 1930. Another motivation in the background is to spread awareness about the role of science in daily life. Developing scientific temperament among citizens is also anticipated as per our constitution, and students, school students and college students, they are our best carriers, I believe. The theme of National Science Day 2025 is empowering Indian youth for global leadership in science and innovation for Vikasit Bharat. The Indian Association of Physics Teachers actively engages school students throughout various competitions, as I said. And in conclusion, I would like to mention that the schools can formulate students groups, and our IPT can help them engage students and provide know-how for various activities. I am bestowed with the responsibility to introduce Professor P.K. Ahluwalia, sir. It is my great pleasure to introduce Professor P.K. Ahluwalia, sir, to this esteemed gathering of budding students. Professor Ahluwalia, sir, is a distinguished figure in the realm of physics, having served as a revered educator at Himachal Pradesh University, Shimla, and now through IIPT, he is for all Indian students and teachers. Throughout his illustrious career, he has held numerous pivotal positions. The list is very long. Professor Ahluwalia's contribution extends beyond the academia. He has chaired various university nodal positions that include Dean of Faculty of Physical Sciences at Himachal Pradesh University and Dean of Planning and Teachers Affairs at the same university. Beginning his career as a teacher through St. Bede's College, Professor Ahluwalia later joined the Department of Physics at Himachal Pradesh University in 1987. He has shared his expertise at various institutions, including UGC Inter-University Accelerator Center in New Delhi and IIT Vadodara. He was adjunct faculty in teaching advanced courses on statistical mechanics and quantum mechanics. Recognized for his academic excellence and leadership, Professor Ahluwalia received prestigious accolades, including Commonwealth Academic Fellowship at University of Edinburgh, UK. Ahluwalia, sir, I would like to mention that the founder of our college, Dr. Punjab Rao Deshmukh, has also worked in Edinburgh University, UK. He is recipient of Best Teacher Award and Academic Administrator Award from Himachal Pradesh University. Beyond his professional endeavors, Professor Ahluwalia is an avid traveler with a passion for science popularization, radio features, writing, and community services. He has made significant contribution to the field through various organization of numerous academic conferences and involvement in various scientific societies. In essence, Professor Ahluwalia epitomizes the essence of a dedicated scholar, educator, and a visionary leader who multifaceted contributions has enriched academic and scientific community both nationally and internationally. I would like to hand over to Professor Ahluwalia, sir, for his address to students.
Thank you very much for your kind words. I'm very happy to be part of National Science Day celebration 2025 here in Nagpur. I am thankful to IAPT Sub-Regional Council 08E, Nagpur, Maharashtra, catering to what we call as the Vidarbha region. And I am really delighted to see so many students sitting in the classrooms, looking forward to know about why we celebrate this day and who was C.V. Raman and what was his great contribution in physics and to the community of science and technology in the country. Thank you, Professor Anwane, for your kind words. Thank you, Professor Lakhotia, for getting me with you here. And I'm also thankful to Somalwar Nicholas School, Nagpur, who have thought of organizing this program for their students. I believe that it is very important that we should keep on speaking to young students and create in their mind a kind of a culture for doing science and knowing that how science can change the society, which we are seeing today. And I think there cannot be better example than Sir C.V. Raman for that purpose. And I think this will help us to see that how things can really move and behave. I'm sharing the screen. I hope my screen is visible. Please confirm it.
Yes, sir, it is visible.
Yes, sir, visible.
So thank you. The title of my talk you can see is, uh, it is written on top, C.V. Raman, a Renaissance man of Indian science. And I hope you will be able to appreciate his contributions here uh, in this auditorium, so that you can appreciate what this means to us. So I think you can always recognize this great scientist in a traditional turban and in English dress. With a tie around his neck, he always wore this dress and he was easily recognizable, even in a crowd. I think that is the mark of the man. And nobody can forget his face. And I think for this audience, dear children, dear young students, dear young minds, it is very interesting to know about his early childhood and education. He was born on 7th November 1888. And you will be surprised to know that he passed matriculation at the age of just 10. It is unimaginable, but it is a fact. His father was a teacher of mathematics and physics, and maybe from him, he actually acquired his interest both in mathematics and physics. You know, to study physics, if you are good in mathematics, it helps a lot. He passed his intermediate at the age of 13. Intermediate actually meant the 12th class. He passed his Bachelor of Art. At that time, there never used to be BSc or Bachelor of Science at the age of 15 with first class, first position from Madras Presidency College. And he passed his MA in 1907. And that was at the age of just 19 years that he was an MA. He was a young researcher. And during his college days, he self-published his first research paper in famous journal Philosophical Magazine. That was in 1906. And the topic is a very interesting topic on light. Unsymmetrical diffraction, bands due to a rectangular aperture. Diffraction is a phenomena by which light bends around obstacles. Normally, we do not see that as such. But if edges are very sharp as that of a blade, and if you try to see the image of that blade, you will find on the edge of the image, light has actually gone and bent and making its presence felt. So this is how he started, with research. But after his MA, he wanted to go to UK for higher studies. But because of his poor health, he was advised against that. And that is when he was given another option to sit for Indian Audits and Account Service examination and see if he can get into that. And as was expected of him, he sat in that exam, passed it with flying colors, and had his first appointment in Calcutta as Assistant Accountant General at a salary of rupees 400. That was in June 1907. So now here was C.V. Raman in the guise of an Assistant Accountant General, AAG, which was a purely financial administrative job, nothing to do with science. But going to Calcutta was a blessing in disguise for him. He came across a board when he was moving in Beau Bazaar, Calcutta, on which it was written, Indian Association of Cultivation of Science. He got curious, as is the characteristic of scientists, and went inside and met a great man sitting there waiting for such ignited minds. His name was Dr. Amrit Lal Sarkar. And he said, yes, we have made this Indian Association of Cultivation of Science to encourage young researchers to come and do their scientific research here. Now, it's very interesting to note that Raman was doing a full-time job. And when he thought of doing research, he could do that only before he went to the office or after he came from the office. So he decided to do that. And Dr. Amrit Lal Sarkar actually handed over to him the keys of the Indian Association of Cultivation of Science. I think this was a great, great occasion in the history of Indian science. Now, what did he research on when he was in Calcutta? Actually, he was very much interested in the musical instruments of India. And he had read a beautiful book by a great scientist, Helmholtz, whose title was Sensation of Tones. Helmholtz was actually a German physicist, and he had written this beautiful book explaining the study of waves and vibrations in a very, very systematic fashion and how these produce a kind of a sensation in our ears. So this was a great, great book which he came across. Raman has written about this book somewhere. And he said, this book influenced my intellectual thinking profusely. I came to know for the first time what is the meaning of scientific research and how it is done. From this book, I gathered many scientific problems which attracted my attention in the coming years and kept me occupied. I think this is a great feeling which Raman shares with the readers of this quotation about the book. So, dear students, sometimes we come across certain books which are life-changing for us. And the study of this book was also a life-changing experience for the young Chandrasekhar Venkatraman. So he decided that he would like to work on Indian musical instruments, percussion instruments, stringed instruments. Percussion instruments are like dholak, mridang, dafli, and so on. String instruments are sitar, violin, tanpura, iktara, and so on. So try to imagine that a person is getting interested in the musical instruments. Maybe he loved music. That was the reason that he chose to work on these instruments, and try to see how a young person can think of doing some research as a project on something about which he or she wants to know more. And I think this example of Raman is the best way to feel inspired. In fact, he was an authority on the study of musical instruments. And one of the first papers which he published from Calcutta was the Iktara. Iktara means one stringed instrument. On Durga Puja or on some festivals, you will find people selling Iktara and playing them with the help of a bow itself. He also wrote some other very interesting articles like escalation of the stretched strings, musical drums with harmonic overtones. It was published in Nature. On some Indian stringed instruments, it was published in Proceedings of Indian Association of Cultivation of Science in 1921. The acoustical knowledge of the ancient Hindus. Try to see. This he wrote for a very special silver jubilee volume, which was printed out in the celebration of Sir Asutosh Mukherjee, who was the Vice Chancellor of Calcutta University. Indian musical drums. He wrote that paper in 1934. Try to see the titles of these papers and how he must have been trying to do these things. He wrote 13 papers on the theory of violin and one on the pianoforte. In fact, his monograph on musical instruments and their tones in the famous German handbook of physics called Handbuch der Physik makes only passing reference to his own work on the Indian musical instruments. And he gave preference to, give prominence to the musical instruments and their tones, the work which was done by others. Raman's work on the Indian musical instruments is a pioneering effort at understanding the scientific principles behind the construction of these instruments, especially the way they achieve the desired tonal structure. Tonal structure actually means that why a sitar sounds like a sitar, why a bansuri sounds like a bansuri, why a dholak is different from mridang, why a veena is different from violin, and why a veena is able to produce the harmonics which very much are akin to the human tonal values. Now, these are some of the subjects on which he actually worked. Dear students, as I am talking to you about this all, in the year 2013, we celebrated 125th birth anniversary of Sir C.V. Raman. So we had a set of MSc students and they were interested in doing a project. So when we sat together to decide the topic, a suggestion emerged that because this year is being celebrated as a silver jubilee of Raman's birth, why not look at his work? The instant reaction which can be there in the minds of students or a teacher can be that let us look at what he did in that area in which he got a Nobel Prize. But we picked up a topic which is called Raman's Musical Physics Revisited. And I think both my students and I enjoyed doing this particular project. Almost for 10 years, Raman worked in the Indian Association of Cultivation of Science as a part-time research scholar. But I think that was a great training time and confidence building time for him. And seeing his dedication, he was invited by the then Vice Chancellor of Calcutta University, Sir Ashutosh Mukherjee, to come on a special chair called Professor Palit's chair. So he had to take a decision. He was getting a salary of around 1,000 rupees at that time, and it was a huge money. The Calcutta University was not in a position to pay a salary of rupees 1,000. And they said that we can only give you a salary of rupees 600. Look at the passion and the love which Raman had for physics and his research. He decided to join this new position at a rate of rupees 600 per month only. I think it was good that he took that kind of a decision, which decided the path which Indian science was supposed to take in the next 13 years. When he did his research in Calcutta, you know that when we do research, what we need to do, we need to ask questions. And some of the questions which he asked were very interesting. For example, he asked why the notes of Veena and Tanpura match with the notes of human vocal cords. Dear students, you must have observed in a Sangeet Goshti, when a singer is singing, he is always accompanied by a Tanpura, because Tanpura tries to match the human vocal cords also. And then he was also very keenly, studying that book of tones by Helmholtz. And he had done certain experiments in which he found that a famous Helmholtz principle is violated in the case of Veena and Tanpura. Dear students, whenever any scientist sees a violation of a law, they actually get very alert and they try to find what must be the reason. And I think Raman really enjoyed these kinds of moments. So I was referring to earlier an article which was published by him in Handbook of Physics, and its title was Musical Instruments and Their Sounds. Let me tell you one very interesting story, that how he got into musical instruments. It has something to do with his wife. Actually, when he was studying, he had a friend, and he went to his home one day, and when they were sitting together, he heard somebody playing on a sitar in that house. So he asked his friend, who is playing this sitar? He said, it is my sister who is playing this sitar. So he requested his friend, can I go and hear that sitar? He said, why not? Come on. So he was taken to that room where his sister was sitting and playing sitar. He sat there and he was so much impressed by her that when he came back, he decided that I think I must choose her as my life partner. Let me tell you, this is the early 20th century era. In 20s, we are sitting. And to marry her was a very, very bold decision by Raman, because Raman belonged to a higher caste in Brahmins, whereas Lady Raman actually belonged to a caste which was also Brahmin one, but was considered lower than that of Raman. So the family, opposed it, that no, you cannot marry her. So he said, look, I am going to either marry her or I am not going to marry for life. Ultimately, the family, agreed, and he married her, and she was his life partner for life, in fact. And, when he went to Calcutta University, Sir Ashutosh Mukherjee was a great mentor. He was mentoring him and he was inspiring him that to know something what is happening in these big areas of science, why not you go to England and attend a Commonwealth Universities Congress? That was in 1921. So he went by sea journey. And that was on the insistence of Sir Ashutosh Mukherjee, who gave him a grant to travel to England. And during this journey, he posed himself this question: why is the color of the sea blue? I think that was, once again, I would like to tell you, dear students, a kind of a lifelong, uh, you know, uh, engagement with the study of light itself. So this is very, very interesting part of the whole story. Okay, so why is the color of the sea blue? There was one explanation which was given by Lord Rayleigh, and he had given a very simple explanation that the blue color of the sea is merely a reflection of the blue color of sky. But on reaching back Calcutta, Raman conducted experiments and concluded that blue color of the sea is because of molecular scattering of light. And in fact, this became a theme of his PhD thesis. So in 1922, he wrote a original thesis on this topic on molecular diffraction of light, for which he earned himself a degree of Doctor of Science, or DSc, what we used to call at that point of time. Now, I am actually slowly and steadily moving towards how Raman did a discovery for which he got a Nobel Prize. I hope you are able to see the screen here, and maybe you will feel inspired also what I am going to really tell you. I'm just trying to adjust certain things on the screen so that you are able to see what is written on the screen systematically. Actually, he was inspired by a very interesting effect which was observed by Sir Arthur Compton. It is an effect which is named after him. Now, mostly, dear students, when somebody is going to teach you about light, he or she, your teacher, may tell you that light is a wave. But Einstein, I hope you know the name of Albert Einstein, in 1905 had suggested that light also behaves like a particle. And the particle of light today we call as a photon. So to prove this fact that light indeed is a photon, a very conclusive experiment was done by Compton, in which he actually threw light on a metal in which the light, when we think of it as a stream of particles, hit an electron and got scattered. And what he observed was there that the light after scattering has got a wavelength different from the light which was incident. And he was able to calculate what is known as Compton shift, that is change in wavelength. It was a typical quantum mechanical phenomena. Dear students, 2025 is being celebrated as International Year of Quantum Science and Technology. And I think maybe you are hearing about this phenomena here for the first time regarding quantum mechanics. And in fact, this experiment established the particle nature of light. In fact, it was not the visible light which was used for these experiments. It was done with the help of X-rays, which are also electromagnetic radiation, or electromagnetic waves, just like the visible light, but of very, very different frequency and wavelength. They are very high frequency waves. That means the energy of these waves is very, very strong. And that is why, whenever we go for X-rays, you must have observed that X-ray wala, when who is taking your X-ray, wears a coat, a shield. When he has to press the button, he goes behind a shield so that he may not get exposed or overexposed to the X-rays itself. Now, this experiment was the inspiration of Raman. That is very, very important to remember. And he once again asked a question. Dear students, asking questions is one of the professional, ways by which scientists work. And if you also develop that kind of an attitude, let me tell you, people will say, oh yeah, this boy and this girl have got what we call scientific temper. So he asked this question, can ordinary light, not X-rays, when it gets scattered by atoms from ordinary matter, change its wavelength? And what he found was that it was not merely Compton effect, but was much more than that. So he had something great in his hand when he observed the scattering of ordinary light by some liquids. And when he had achieved that discovery, he sent a news item to Associated Press that a new discovery has been made, and he even gave a name to it as Raman effect. In fact, on 27th February 1928 in Calcutta, he had also called a conference of newspaperwalas, and to them also he declared that he has discovered something very new. Dear students, it is very interesting to note that a Nobel Prize is given to a person who discovers that, first of all. Anybody who finds it later is not considered as something great. And there was a lot of competition at that time. There were many other people who were working on this problem. But it was a good, situation that he could discover it first. He was very much knowing that he has to tell world also that he has discovered first. And that was the reason he also got a Nobel Prize for this. But then you will ask me that what is this Raman effect and with what instrument he actually achieved it? He did that with the help of what is shown in this picture on the side. It is from the museum where that spectroscope is actually a kind of an optical instrument in which you can imagine that there is some kind of a medium like a prism on which light is falling, and light may then get split into colors. I'm talking of ordinary light, white light. But you can always modify it and do very many other things with this instrument to study the behavior of liquids under light. And what Raman found in the case of his effect was that the wavelength of light is changing not because of electrons as was found in the case of Compton, but because of their scattering by atoms and molecules. And this can be understood very easily. Please remember, today when we have to do Raman effect, we make use of lasers for doing that. Because this effect actually requires light of very high intensity before the scattering occurs. So from where was he getting that light? He gathered sunlight, passed it through a violet filter to get a violet light. Now, once it is violet, it has a specific wavelength. And he made it pass through a liquid, which we can imagine as a scattering liquid. And then he found that when this light gets scattered, it has got not just one part, but two parts. One is the original light, other is a light whose wavelength is different from the original light. In this case, it changed to green. And to make sure that the green light is there, in the path of this light, a green filter was put to observe whether the green light actually comes out or not. And that is what was found. So this is a very simple experiment which explains us. Today, we find that Raman spectroscopes are a common item in the lab of a chemist or in the lab of a physics wala, in a pharmacy, company, you will find that they are using Raman spectroscopy or Raman scattering. And as I was telling you, that it depends upon the atoms and molecules. What is the implication of saying this, that depends on the atoms and molecules? Implication is very simple, that it is characteristic of the atoms and molecules from which it is getting scattered. So you will ask me one question. Does that mean that with the help of Raman effect, we can identify these atoms and molecules? Answer is yes. And we must also remember that this result was one of the confirmations of what we today celebrate as quantum science or quantum mechanics or quantum technologies. And there are three things which we can actually state in seeing it as a quantum mechanical phenomena. First is interaction between light and molecule excites the molecule to a higher energy state called a virtual state. Some of you who are sitting here in this lecture from class 11 or 12 must have learnt about Bohr's model of an atom, in which around a nucleus electrons move around circular paths in different orbits called stationary orbits. And when an electron from a higher orbit falls to a lower orbit, the light gets emitted. Now, what we find is that when light actually interacts with this molecule, the molecule goes to a higher energy state called a virtual state, which is a kind of a temporary state. And that means that it will have to come to the ground state and release energy. Also, there was another thing which was thought regarding it, that the molecule then undergoes a vibrational or rotational transition between energy states. So try to imagine water molecule. Light hits it, it starts vibrating, or maybe it starts rotating about its axis. Its state changes. This transition is governed by selection rules, that which determines the allowed transition between energy states. So when the molecule returns to the ground state, as I said earlier, it emits a photon, which is a scattered photon. And energy of this scattered photon is different from the energy of incident photon due to energy transfer during the vibrational or rotational transition. So this difference in energy between the incident photon and the scattered photon is now not called Compton shift, but is called Raman shift. This shift is characteristic of the molecules involved and provides information between its vibrational and rotational states. Dear students, let me tell you that what I have explained to you in these 4 lines is of great consequence to people who are studying chemistry. Suppose a chemist discovers a new compound and he or she wants to know what is the structure of this new compound. You know what do? They go to the Raman spectroscopy, try to study it there, and then try to see whether they can now predict the structure of a new compound which they have synthesized in the lab. So do remember one thing, that there are some key quantum mechanical concepts which are involved here. One is virtual states, second is selection rules, third is energy transfer. You know, when people came to know about this Raman effect, they started giving their impressions and comments. Albert Einstein was one of the first to do that. And he wrote that C.V. Raman was first to recognize and demonstrate that the energy of a photon can undergo a partial transformation within the matter. I still recall vividly deep impression made by this discovery on all of us. Imagine the person who thought about a photon had kept an eye on what Raman was doing. And that is how he is describing his feeling of this great discovery. You know what happens to discoveries? Once these are made, people get interested in those. And after a period of time, you know, their interest just goes off. But this has not happened in the case of Raman effect, thanks to the discovery of lasers, which gave a new life to the use of Raman effect in chemistry, pharmacy, physics, chemical engineering, you name anything, you will find that people have some very interesting, usages for this. After this, Raman went on a world tour also. And he went to the Bell Labs where he met a set of scientists who later became very, very famous. And he was shown there the beginning of a semiconductor laser, which was actually nothing but dependent on the Raman scattering process. And in this picture, you can see that there are two Nobel laureates who are sitting. One is sitting just below Raman. You can see him with a turban and a person sitting below. His name is Walter Brattain. He was the one who actually was responsible for the discovery of transistor, which has changed whole of the technology on Earth. I'm once again saying, change the way we live even today. And the other person was John Bardeen. He is standing here. I hope you can see with the cursor. Bardeen was the person who got Nobel Prize twice. One for the transistor and other for the superconductivity. So this is a very interesting, story. Another person with whom Raman had a friendship was R.A. Millikan. I hope those of you who have studied that atom has got an electron and it was discovered by J.J. Thomson. It was Robert Millikan who found what is the charge on the electron, what is the value of the charge. And Raman actually visited, before getting Nobel Prize, USA for a lecture tour. This picture is actually of Millikan when he visited him in the Indian Institute of Science, Bengaluru, after he had become director of that institute itself. Now, when he actually went to USA, he went to a famous university called Caltech, California Institute of Technology at Pasadena. And there he was introduced as a great speaker and a scholar who was going to talk on a subject, a game of chance. And this was actually also highlighted in the local newspapers. So one of the papers stated that as professor of thermodynamics, mind it, we are not calling it as a professor of light scattering. We are calling it as a man who is actually interested in heat and thermodynamics, who is in the University of Calcutta. He is known as one of the foremost authorities on natural science in Asia. He is in Pasadena as a special lecturer on physics at California Institute of Technology. And while introducing him, one of the presidents of the university club there introduced him as follows. He said, most Hindus coming to this country talk on philosophy and the occult. And it is a distinct nobility to have one who is more in accordance with the Western scholarship. So now you can see that he was being seen as a flag bearer of scientific temper in a country called India. And who was the speaker and what was the topic? A game of chance. And there was a report which was published in the newspapers. Maybe when this lecture is happening, somebody may write a report and give it to the newspaper wallas. So when Raman's lecture was going to be described, he was described as Dr. Raman proved himself an entertaining speaker, displaying a delightful strain of humor. He began by stating that games of chance had always held a deep fascination for the human mind. In support of this, he recalled several legends from the ancient Sanskrit, according to which humans played at dice with the gods. Drawing interesting analogies between games of chance and the issue of life, Dr. Raman said, there really was no such thing as chance because everything happened for definite reasons. but those for which the causes were not known were characterized as chance. And further, that said, in the course of his remarks, Dr. Raman described some of the experiments that famous mathematician had conducted to work out the details of the law of probabilities, recalling battles that many university club members themselves had fought with sequences, choice, and chance in their college days. Fascinating too were his remarks on the law of irreversibility, something which he said few people ever thought about. It was an evening of mental gymnastics, which Dr. Raman concluded by saying, the greatest game of chance of all is nature, thus adding a touch of the mystical and giving the audience something more to think about. He also gave a lecture on study of musical instruments because he was considered at that point of time an authority on musical instruments in the world. So, a notice was given and displayed on the notice board in which it was written, the Friday evening demonstration lecture this week at the California Institute of Technology will be one of unusual interest, both because of the personality of the speaker and because of his subject. Dr. C.V. Raman, professor of physics at the University of Calcutta, India, will be the speaker, and his subject is the study of musical instruments. Dr. Raman stands out as one of the most productive scientists of the Orient. He has already done a surprising amount of high-grade scientific work himself and has simulated a great deal among other students. His publications on mechanical theory of stringed instruments have made him an internationally known authority upon the subject about which he is going to speak. And then, this lecture's report also was published. And it was mentioned in that he had brought personal enthusiasm for his subject. Let me tell you, dear student, he spoke wonderful English. He was a master of English language. He was known for giving his lectures to common man in English on radio. Those are the lectures which are available on the internet, and I will very strongly recommend that you should go and hear that. I remember when I was studying in school in class 10, in our English textbook, there was an essay written by Sir C.V. Raman, and the title of that was Elixir of Life. And that was an essay on water. And, he had taken with him number of musical instruments which he played there to tell what is so unusual about these instruments as per his research. So this is how it was actually announced. And these lectures were very well received. He was given a lot of, applause for that. More than 300 people attended that lecture. And he was also introduced in many other ways in this particular case. Let me tell you another thing which is very interesting. When he was to be nominated for Nobel Prize, one scientist, a very famous scientist, Arnold Sommerfeld, was visiting India. And he visited him on 4th October 1928, and he stayed there. And he saw the Raman effect and heard a very interesting lecture from Raman himself. And this was the Raman effect with the help of ice. So that was actually that when the light was falling, ice molecules were rotating and the radiation was getting modified. And he was so convinced that when he went back, he made sure that he nominates Raman for Nobel Prize. And when he was leaving, he said, India has suddenly emerged in research as an equal partner with her European and American sisters. Dear student, these are not small statements. They're a big statement. Raman made us feel that we are as good as people in the Western world. We must not forget that. And, very many other people also explained or talked about his discovery. And they said that we have verified it. One such person was an optical physicist, R.A. Wood, in Johns Hopkins University. There is one other very interesting, incident, and that is with Satyendranath Bose. I hope you have heard his name. He was the inventor of Bose statistics, and he was a member of Raman's physics department at the university in Calcutta. And he was walking with him on a walk in the evening. And he told him very quietly, Professor Raman, you have made a great discovery. You will surely get the Nobel Prize for it. And I think that was a statement which became true later. This is a great picture. In 1930, after he got a Nobel Prize, the Queen actually honored him with the what we call prefix, which you could put before his name, called Sir. Sir C.V. Raman. That's why most of the times you will hear people saying Sir C.V. Raman. But don't forget, he is also one of the Bharat Ratnas, first Bharat Ratna from the country. And here you can see Sir C.V. Raman in an unusual dress. He is not wearing his turban. But I think you can see a knot at the back of his head of his hair, showing his Brahminic, link. And he is holding the Nobel Prize citation in his hand for the picture. In fact, after this, he became director in 1933 of Indian Institute of Science. But there was a lot of, controversy. People never wanted him to be there, so he resigned. Until 1948, he remained head of the physics department at IISc. And his interest after retirement was in making an institute of research. And that is how Raman Research Institute actually came up in Bangalore, on an area which was gifted to him by the king of Mysore. And he was studying colors in gems and minerals there. He also studied artificial diamonds by X-rays and gathered new information. And he actually gathered gems and minerals in his museum. In 1954, he was given Bharat Ratna, and he left for his heavenly abode on 31st November 1970 at the age of 82. And this is one of the last pictures of the C.V. Raman. And the tree which you are seeing in this picture is the place where he was cremated in the Raman Research Institute. He wanted this to be the way he should have been treated. And see, a living plant is standing at that particular place, symbolizing Raman himself. Now, at that time, when he passed away, the president of the country was Dr. V.V. Gari. And he was given a great tribute by him. And he said Raman was a great teacher. His knowledge was not limited to physics alone. In the present era of specialists, his sweep of knowledge was very profound. He had highest intellectual honesty and a warm personality. He was our greatest scientist who led the country in progress of science. I think this was a great tribute. And I would like to now take you from where I am giving you the lecture. I am sitting in Shimla, and this picture which you are seeing here is of a very interesting academy in Shimla. It is known as National Audits and Accounts Academy. Raman started his career as Assistant Accountant General. In this academy, a museum has been created in which the furniture and the table, which Raman had used in his office at that time, has been kept for visitors to see and feel inspired. I have visited this place, and one gets a sense of aura by looking at these memories about Raman. So what was the meaning of science for C.V. Raman? He always saw science as a convergence of human intellect and sense of beauty, which is dedicated to study and understanding of nature. This is why it is the apex symbol of creativity. What are the uses of effect? It is a great way to detect cancer cells. It is also known as a device for fingerprinting. When I am using this fingerprinting, I'm actually referring to how it can identify atoms and molecules in materials. And in his Nobel lecture, he had anticipated that the study of scattering of light will help reach knotty problems of physics and chemistry. It presents itself as a solution to many problems in physics and chemistry because of its ease to use, its far-reaching influence, and its simple spectrum, which a high school student can also understand. Dear student, I'll tell you something very interesting in the end. When he got a Nobel Prize, his grandmother actually got very excited about it. And she was not realizing that what is so much in this, what Raman has done. So she asked Raman, can you explain me what you have done? And Raman explained her, and that she felt so happy after knowing that what he has done. This was a clear signature of Raman's way of communicating science to ordinary people, for which he was a master. And I think on this day, when we are celebrating National Science Day, we must pay our tribute to this great humanitarian, a great scientist, a great leader of science, which was born in our country. These are some of the references which I have used. Journey into Light, Life and Science of C.B. Raman. This is a very authoritative biography of Raman. I will suggest that when you have vacation, catch hold of this book and read it. There is another very interesting book written by A. Jayaraman. It is Chandrasekhar Venkat Raman, a memoir. A. Jayaraman was a student of Raman himself, and it is downloadable from the Indian Academy of Sciences website. Also, you will find on that website, there is a pictorial biography of C.V. Raman. Some of the pictures of Millikan, etc., I have taken from that book itself. So I think I am at the end of my lecture. I hope you enjoyed it. Thank you very much. And I'm coming back to you for any questions you would like to ask me. So here I am. And let me go full screen. I hope you are able to see me, and hopefully you have enjoyed the lecture. And the best part is that this lecture was being telecast in different classrooms, which I can see on the screen by the numbers of the admins who are there. And I think I must thank Professor Anwane, the principal of school, my association with Shivaji Science College. I think that is getting stronger and stronger. Professor Lakhotia is a kind of an inspiration for me who does these kinds of things. And I can see that more than 500 students must have been sitting in this lecture. I'm really thrilled that you were there in this lecture. Thank you very much.
So thank you very much for very nicely feeding students, budding students. And I think at the school level, a person like you, who is well recognized in the country, is speaking on the occasion of the National Science Day. I feel that this is a great opportunity for the school boys and our students at Shivaji Science College to spend time on such an issue and taking glimpses of what C.V. Raman has done and where he has worked and what was his real contribution. I appreciate you. I acknowledge your efforts to making it to reach to students at large, and the blessed students I can see who are benefited by your lecture. Now I would request Madam from Sumalwar College, Sumalwar School, to gather questions from students. We can address few questions at this moment. And I think Professor Ahluwalia sir would be very happy to interact with students through questions. Over to you, madam.
Yes, sir. One of the students have the query, sir.
Hello. Is somebody asking?
Yes.
Good afternoon, sir. My question is, what is quantum mechanical concept? Quantum mechanical concept.
Actually, I think you should come nearer to the computer and then say, because I will
My question is, what is
not use the mic.
quantum mechanical concept?
Come to the computer, near computer, and then say. Otherwise, there is a lot of echo actually coming. Where is the computer here? Somewhere if he can go near that.
So she is asking, what is quantum mechanical concept? Am I audible, sir?
Yeah. Can you write it in the chat box, because there is something which I'm not able to hear. Actually, when you hold this mic, etc., in the hand, it is not audible like that.
Sir, the little girl wants to ask, what is the quantum mechanical concept?
Okay, all right. Dear student, keep standing so that I may see you. I have heard your question now. Come back. I should see you on the screen. Let me just try to explain you. You know that in daily life also, when we go to the market, you know what happens? Somebody says that I want a toffee, right? And the toffee wala says, look, you can have full toffee, you cannot get half the toffee. So that means toffees come in small packets, which you can have. And then you are supposed to pay for the toffee. And that says pay, the cost of the toffee is 1 rupee. So you will always, when you buy toffees, you will pay in the packets of 1 rupee itself. Now, this is a very simple idea. Now, what we find in physics, in nature, is this, that energy, when it goes, as I was telling you, light is energy, and when it travels, there are two ways to look at it. One is that you see it as a wave. Other is that you see it as made up of particles. But these particles are of what? These particles are of energy, because light is energy. So when somebody says that I have a light of frequency nu, then let me tell you, in quantum mechanics, we will say it has got energy h nu, where h is a Planck's constant. So when you have a light of energy nu, you will always find packets of h nu in it. And that is what is nothing but a quanta of light. This is what is the meaning of quanta. I hope you have understood it.
Yes, thank you, sir.
Thank you. Good.
Thank you, sir. Yes, sir. One more question.
You should make me help understand it also. Anwane sir?
Yes, sir. Yes, sir.
So my query is, what was his contribution in thermodynamics?
Please unshare your screen so that we can see you on the main screen.
Yeah, I am able to see him.
Sir, what was his contribution in thermodynamics?
Can you repeat, Professor Anwane?
Yes, sir. The boy wants to ask, what is the contribution of C.V. Raman sir in thermodynamics?
Oh, yeah. Actually, he was at that time, I think you have heard my lecture very carefully. I'm very happy to know that, dear student, that you uh, heard that I talked about that he went on a lecture tour of USA for teaching thermodynamics. In fact, he didn't do directly any work in thermodynamics, but he actually was teaching thermodynamics as a subject in the Calcutta University. But two of his colleagues, whom I have mentioned also, one was Satyendranath Bose, other was Meghnad Saha. They both were working on thermodynamics. And there was a lot of influence of these two people also on Raman to understand and explain to his students thermodynamics. That is how it happened. And please remember one thing more. When we are working in some institution, like teachers also keep on talking with each other about what are you doing? Am I also in a position to understand that? So I think this was a kind of thing which was happening in Calcutta University Physics Department. Meghnad Saha and uh, people like Raman, they were interested uh, in what you can call as thermodynamics. But he himself didn't make much contribution in thermodynamics. I hope you got answer to your question. Okay, thank you. Very good. This Somalwar school is a good school. Yeah.
Good afternoon, sir.
Good afternoon.
What is we call post statistics?
Anwane sir, please.
She wants to ask about Bose-Einstein statistics. What is it?
Oh, okay. Bose-Einstein statistics. Wow, what a wonderful question you have asked. So you know Einstein, and you know Bose also, and you know Raman also. And in Raman's lecture, it is very natural that somebody may ask about Bose. And let me just tell you something like this. What is statistics actually? Statistics is a way of looking at the things around us and counting them to know about their characteristics. For example, if I am in your school, I may make use of statistics to know what is the average weight of a student studying, say, in class 11. So what I will do is I will count the number of students. So counting is involved in it. So in Bose-Einstein statistics also counting is involved. Now let me tell you another very interesting thing. Suppose we have three things which I can distinguish. Suppose there are three students from your class. One you are, then there is another one, and there is a third one. And I tell them, look, let's stand in a line as three students. And then, I will start making them shuffle their positions. And then I will ask them that in how many ways I can arrange you. You know what I am doing? I am counting the number of ways of arranging. Okay. And how many ways are there? First place can be filled in three ways. Once it is filled, second can be filled in two ways. Once it is filled, third can be filled in one ways only. So I know that I can have how many ways? 1 into 2 into 3, that is 6 ways. This is simple counting. In Bose-Einstein statistics, we do counting not of something which is distinguishable, like three students whom we can identify, but those things which are not distinguishable. An electron cannot be distinguished from another electron. So in quantum mechanics, the fundamental particles, the electrons, photons, etc., they are indistinguishable. And this is where Bose tried to explain what is known as black body radiation spectrum and derive by a very different method a formula which was given by a person who first of all explained black body radiation spectrum. His name was Planck. You must have heard that the Planck constant appeared in the lecture itself, right? And because this was a new way, and he was for the first time talking about indistinguishability of particles, new statistics came up. And when he wrote a paper, he sent that paper to Einstein that can you please translate this paper from English into German and get it published? Einstein saw the importance of the work and he got it published. And that is why we call this idea of indistinguishability, which was a big idea, in memory of both Bose and Einstein. But the original idea was of Bose. That's why his name comes first. Light is also a Bose particle. When we say light is a particle, photon is a Bose particle. We call it as boson. So don't forget what is a boson. Half of the particles in this universe are bosons. And we classify these particles into two kinds. One bosons, other fermions. I think I cannot go at more length than this in this lecture, but I hope you have enjoyed the explanation.
Yes, sir. Thank you so much.
Okay.
Thank you so much, sir. Just last question, sir, by one more student.
Yes. Sir, Anwane sir, please let me help the question also.
Yes, sir, I am ready, sir.
Sir, my question is, how does the key quantum concept works?
How does the
Key quantum concept works.
I'm missing your audio. Please say it again.
How does the key quantum concept work?
Sir, he is asking about some key quantum kind of concept.
Can you repeat it?
I also could not get his question clearly.
Bete, mic, take this mic in front of your mouth and say it again. Yeah.
So, how does the quantum concept works?
How does the key quantum concept works?
How does the
Key quantum concept.
Which quantum concept?
K-E-Y, key quantum concept.
K-E-Y, key quantum concept works. In what context? You will have to tell me context. Context, you know what is the meaning of that?
Any answer, sir.
I didn't get it.
Sir, in the key quantum concepts about the energy transfer.
Okay, all right. Now this is interesting. I talked about Bohr model. Do you remember in the lecture that there is a nucleus in an atom around which electrons are moving in different orbits? You heard about it, na? And you know, when an electron from lower orbit, say first orbit, it goes to second orbit, we have to supply energy, which is in a specific value. That specific value of energy is a quanta of energy only. When it falls back, the same energy gets released also. This is again a packet of energy only. That's why we are calling it as quanta of energy. And because packet of energy is what? A photon. So you are actually finding that photons get emitted. So in the spectrum, when you are seeing different colors, you are actually finding that these colors correspond to the jumping of electron from one orbit to another orbit in a specific sequence. Okay. And Bohr also gave us a formula about energy of an electron in a particular orbit with principal quantum number n. And that formula is actually equal to minus 13.6 divided by n square in electron volt. So in the first orbit, energy is minus 13.6. In the second orbit, the energy of the electron will be minus 13.6 divided by 4, which is minus 3.4 electron volts. So what is the difference of minus 13.6 and minus 3.4 electron volts? That is the energy which will get released. And this is what is a quantum of energy which is getting released. Always you will find this amount of energy will be released. I hope you got it. I didn't confuse you further.
Okay. Thank you so much, sir. As we are concluding the celebration, it is now my sincere duty to express our heartfelt gratitude to our esteemed guest, Professor P.K. Aluwalia, sir. Sir, you are source of inspiration to many, and we are very much honored to have you with us today. Please accept our deepest gratitude for sharing your knowledge and expertise.
Thank you.
I thank Dr. Shamkant Anwane sir for being with us. I extend my gratitude towards Dr. Govind Dakhotia sir for making this webinar a reality. I extend my heartfelt gratitude towards our visionary principal, respected Damodar Thongre sir, as well as supervisors, Mrs. Pathekar ma'am, who always stood by us, guide us, and support us. I extend my gratitude towards supervisor, Mr. Sandhi sir, and most importantly to all these students who are very curious and eager and enthusiastic and ready to learn. Thank you so much, sir. Last but not the least, I also thank my technical team, non-teaching staff, Shubham sir and Umesh sir, for keeping all the arrangements ready for the smooth conduction of this program. Thank you very much, sir.
So I would like to leave now. Thank you very much, ma'am. And thank you, children. Enjoy the day. Enjoy the National Science Day. Thank you very much.
Sir,
Thank you very much, sir.
sir, good afternoon. Sir, our one student wants to ask you a question.
Yeah, please, please.
Is Yugansh come?
Yes. Yeah, Yugansh, yes, please. Oh, yes, Yugansh is my friend. Are you not my friend? Do you remember me?
Yeah.
Okay.
So I just had the question about it. You were talking about the electron state cycle, the energy levels, and what if there are researches going on in that field right now, and what if the photons somehow tunnel into high energy levels without crossing the earlier ones? So is there anything of research happening on that particular topic? Quantum tunneling of photons so that they can literally go to another energy level without crossing the existing levels.
Yugansh, I hope I have understood your question. Let me repeat what you are asking me. If it is okay, then I will proceed further. You are asking me that an electron can jump to a higher level, right?
Crossing the earlier
And
by
come back
quantum
to
tunneling.
some other level, isn't it?
Yes,
Let
sir.
me just explain you one thing very clearly. I will take the example of hydrogen atom only because that is the simplest to explain. Now we have principal quantum number called n is equal to 1, 2, 3, 4, 5, 6, and so on. So, and I was just talking about that n is equal to 1 corresponds to minus 13.6 electron volts and so on. You know that electron can go to any higher level provided we provide the right kind of energy. Now, suppose an electron goes to first level, beyond the ground state. Okay, n is equal to 1, n is equal to 2 is beyond the ground state, n is equal to 1. It can go to n is equal to 3, it can go to n is equal to 4, and so on. When we are seeing hydrogen spectrum, we are not seeing just one atom of hydrogen. We are seeing a large number of hydrogen atoms in which, in one case, electron may go from n is equal to 1 to n is equal to 2. Another may go to n is equal to 1 to n is equal to 3, and so on. Now you will find that when from a higher orbit an electron falls to a first orbit, whether 2, 3, 4, or 5, you get a bunch of lines. These lines are given specific names in the spectrum. For example, in the visible spectrum, this set of lines correspond to Balmer series. Okay, and this is in the visible region. So what is that n in which the electron falls from higher orbit to the lower orbit gives me different series. If electrons are coming from higher to first, I will get one kind of series. Coming from higher to second, I will get another kind of series, and so on. So I hope that explains your question, what you have asked me.
My main question was around quantum tunneling. Like what if
Okay, around
electrons just
quantum tunneling.
tunnel and go to upper level?
Ah,
Yes,
right.
sir.
Okay, all right. Now let me come to that. So in the hydrogen problem, there is nothing of the kind of quantum tunneling which is happening. But now try to see a situation in which I want, because I am a small kid, to not go uh, up to the top of Himalayas and come down to the other side. I would say if somebody had made a tunnel and if I passed through that, I would be very easily able to reach the other end. But now this kind of a thing is not like this the way we are seeing it. Sometimes when we want to explain something, our words don't fully explain that us. So you will ask me, what am I talking? See, at one point I am talking that the height of a mountain is like a huge potential energy. You will have to overcome that potential energy to go to the other side. Quantum mechanics says, look, it is like this, that when we are talking about an electron, where it is, there is always a probability associated with it. And I'll give you an example. Anwane sir is in your college, isn't it?
Yes, sir.
And I will ask you, where is he? Somebody may tell me, look, he is in the college, but he's not telling me where he is. Somebody then says he is in the physics department. So now, when I am going from this information from college to the physics department, the probability of finding him is improving. So I want to, make it as small as possible. Quantum mechanics says you cannot be very precise and there will always be an uncertainty in it. So that means somebody comes and tells me, look, that Mount Everest is okay. If I think quantum mechanically, if I am standing on one side of the Mount Everest, there will be a finite probability of finding myself on the other side also.
Yes, sir.
And if this probability increases, in quantum mechanics, we say that we are doing quantum tunneling. Okay. Now, you know that alpha particles are residing inside the nucleus and they come out in the radioactive isotopes. And the potential is very high. They can't come out because, the other protons sitting inside the nucleus will pull them back. But then how do they come out? Classically, it is not possible. But quantum mechanically, they say, yeah, it is possible because there is a finite probability of finding that alpha particle outside the nucleus also. I hope you have got it now.
Sir, I would like to comment in between. The classical deterministic world is not capable of explaining how a particle of less energy can overcome the barrier which is manifold, as sir said in the case of alpha particles. But quantum mechanical explanation given by Gamow could talk about some, estimatable probability of penetration of that particle, and that was given name quantum tunneling. I think we are talking about that. And in beta decay also, you have to consider that. So whenever the particle has less energy as compared to the barrier, then the possibility which cannot be explained classically can be explained quantum mechanically by Gamow's theory.
You guys should know about George Gamow. Have you heard his name?
Yes, I've heard his name in few lectures.
In fact, he was a great astrophysicist and a nuclear physicist together. And he has written beautiful books for the layperson also. And one book which he has written is about theory of relativity, special theory of relativity called Tompkins in Wonderland. Okay. And you know why I am telling you this? Whenever we study physics or chemistry or mathematics, when we want to explain it to somebody, we try to make use of common language to explain it. We are not very precise in explaining that. But this is how thinking about any new thing starts happening. That George Gamow must have thought about, okay, let me say that alpha particle is hidden inside a cave and that wants to come out of it. So he is imagining a model. But then barrier is so high, but still it comes. So can I imagine that there is a tunneling effect? Again, this is a language which is using of day-to-day life. Once they conceive it like this, this idea, what they do is they sit down and try to bring mathematical apparatus in front of them. And they set up, say, a kind of a phenomena to understand tunneling means what kind of equations I need to understand. Do I need to talk about scattering, or can I talk in terms of bound phenomena? All these questions start appearing. And I think the beauty of human mind is this, that with very small inputs, it can reveal, great secrets of nature. And I think that is what we should start appreciating. And once we do that, you will find that it becomes a fun to understand and enjoy basic concepts of any topic, physics or chemistry or biology.
So,
So Yugash, nice to see you again.
thank you, sir. So basically, like we were talking about alpha particles getting out of out of the nucleus by quantum tunneling. What if that similar thing happens in case of photons and other energy barriers? So is there a possibility that in coming future, it will deny some classical theories and maybe Raman spectroscopy itself, and there will be some another quantum theory which would change the understanding of universe for us?
In fact, this is again a very tricky kind of a thing which you are asking. Because if I very frankly admit this, even today people say that we don't understand quantum mechanics very well. Okay. And in fact, the great scientists like Bohr, uh, used to say that if somebody is saying that I have understood quantum mechanics, then he is telling a lie. That is not possible. You will not understand full implications of it. And this is troubling us even when we are celebrating the 100th year of the coming up of quantum mechanics itself, in terms of Heisenberg's phenomena, Heisenberg's matrix mechanics to explain it, or Schrödinger or Dirac. These three people were actually the architects of making us understand the foundations of quantum mechanics. But then there were people like Einstein who, till his death, always used to say, look, God never plays dice. So when you are talking of probabilities, etc., I don't understand it. And that is why, he wrote a paper on EPR paradox, in which he said there is something spooky happening. So spooky is again a kind of a, and these are the things which are very interesting. You should have an interest in these things. It's good. But in science, when we answer one question, it always poses very many other questions also. So we should be ready to catch those questions and think how we can explain it. Asking questions is the most fundamental thing in science. You have to be a doubting Thomas always. You will शकी मिजाज होने की जरूरत होती है साइंस वालों को.
Skeptical.
है ना. और देखो मैंने बोला था आर्नल्ड सोमरफेल्ड he came to Calcutta to check whether Raman has done that experiment or not. Very unusual, you should believe in me. But he was a scientist. He said, no, I will go there and see it. Try to imagine this. See how science operates. That's why, we say that science is having a very different culture. Once Einstein was in New York, and a journalist came to him and told him, look, 100 people have gathered in New York and they are saying you are wrong. You know what was his reply? He said, why 100 people? One is enough. We don't require 100 people to say that you are wrong. One is enough. You can prove it. I will accept it that I am wrong. What is there in it? So you guys, having a nice talk with you. Wonderful. Keep it up.
Thank you. Thank you.
So, sir, thank you very much.
Okay. So see you in the evening.
Yes, sir. Yes, sir. Yes, sir. Definitely.
Okay. Bye then. Lakhotia sir, are you there?
I think
He has left. Okay.
He has some program in his college.
Yes. Okay, fine. So
Thank
bye
you, sir.
then. And I'm